Hey guys, so welcome back to another video. We're on our last section of RF 6 and 7, and today we're going to talk about general form. So general form is represented by the equation ax plus by plus c is equal to 0, where a is a whole positive number and b and c are integers. Okay, so a couple key points here. Like we said, a has to be a whole positive number. So that number beside the x always has to be a positive whole number, no exceptions to that. And b and c need to be integers. Okay, so essentially what that means for us, we can basically come up with a couple things here. There are to be no fractions. And no decimals. Okay, for the entire equation, and more specifically for the a value, the coefficient of x, it has to be whole and it has to be positive. So keep that in mind, and again, make sure there's no fractions and no decimals in that equation. Okay. Now, when we look at general form, it helps us in a couple different ways. We can identify the x and the y intercepts easily. And we can use it when we solve systems of linear equations, which will be covered in RF 9. Okay, now here's a really quick review of what we've discussed so far in this outcome. So let's go ahead and take a look at three different graphs here. So our first form that we discussed was y is equal to mx plus b. Then we also had your point-slope form, or slope-point form, y minus y1 is equal to m times x minus x1. And finally we have ax plus by plus c is equal to 0. Now all of these different forms of linear equations have their pros and cons. The first one here, we talk about the slope and the y-intercept. So we can see the slope in two of these forms. Okay, so if we're given a slope, we can use first or the second form. The first form here with your b value is much more useful if we know what your slope is. Now for this for point slope form, it's much easier if we know another point on the line. So basically, that being said, if I were to draw a couple of different graphs here, and let's go ahead and do this. Essentially, the highlights of these are, we can figure out the slope. For this one, this is best used if we know the slope and the y-intercept. So that is slope-intercept form. Point-slope form is best if we know a point on the line that is not the y-intercept. So point on the line, and also the slope, of course. Now that begs the question, when do we use this third form? Like I said earlier, we can use it for systems of equations, but it's also really useful for helping us to figure out exactly where those x and y intercepts are. Okay, and seeing that in our third example here, we do have 2 points on your graph. We can then figure out the slope quite easily, and then we could really just move it back into one of these two formats. It doesn't really matter. Okay. So again, just to reiterate the fact that all three forms can be interchangeable, they can all be equal to the same thing. We can change them all into general form. So again, remember with general form, we have ax plus by plus c is equal to 0. We can't have any fractions, can't have any decimals, and that value of a, the coefficient of x, has to be a positive whole number. So for our equation on the left side here, we've got y is equal to 2x minus 8. We notice that our x is already positive. We have a 2x on the right-hand side. So really all I need to do is subtract y from both the left and the right side. So I'm going to subtract y, and I'm going to subtract y there. So that means on the left side, I'm left with a 0, and I have 2x minus y minus 8 on the right-hand side. So there is my general form that I just converted into. And just note that even though here I have 0 is equal to this, 2x minus y minus 8, you notice that here we have something plus something plus something is equal to 0. We can really just rewrite it like this. 2x minus y minus 8 is equal to 0. So both of these are mathematically equivalent to each other. It's kind of like saying that we know that 2 plus 2 is equal to 4, or we can say that 4 is equal to 2 plus 2. Those are equivalent to each other. Now with our example on the right here, I'll do this one in red. You want to make sure we get that x by itself, but we have to simplify the right-hand side first. So I'm going to go ahead and distribute. So I'm going to have 3 times x and 3 times 5. I'm not going to worry about that left side just yet. So I'll have y minus 4 is equal to 3x plus 15. Oh, that looks like a 13. So plus 15. Now we notice here that the 3x is already positive. We don't have any fractions or decimals in this equation, so we're okay. So I want to keep the 3x on this side, and I'm going to subtract a y, okay, and then I'm going to add 4. So let's do it one step at a time. When you guys become a bit more proficient with this, you guys can go ahead and do them all at once. So I'm going to subtract y from both sides. Then I'll have negative 4 is equal to 3x minus y plus 15. And then I'm going to add 4 to both the left and the right side. And I'm left with 0 is equal to 3x minus y plus 19 as my general form. Or I can go ahead and flip it around and say 3x minus y plus 19 is equal to 0. Those are both exactly the same. Now again, if you're having troubles with the algebraic steps of this idea or concept, you can go back into a video that I uploaded earlier. I'll put a link up or a little pop-up in the video. So take a look at that if you do need some extra practice. So we're going to do a few extra practice questions together. Again, I just want to highlight some of these pages that you can go to and look at those questions in your textbook for extra practice in relation to this particular concept. Again, I'd like to stress that you guys should be pausing the video after every question or before every question to try it out on your own, and then unpausing to check to see if you've gotten it right. So question number 1 here, again, we're going to make sure we keep our x's positive and a whole number. So we only have whole numbers here. We don't have any decimals to worry about. So I'm going to move that y to the right side. And I'm going to do that by subtracting y from both the left and the right side. And I have 0 is equal to 2x minus y minus 8. For the next one, more or less the same thing. I'm going to subtract, I'm not going to subtract y, because in this case I have my negative 3x here. I'm going to add 3x to both sides first. So I'll have 3x plus y is equal to 2. Then I'll subtract 2 from both the left and the right side. Again, some of you guys might come up with some different methods of solving these. That's absolutely fine. As long as we end up in the same place, then we're going to be looking pretty good. Now, this third example is where we start to run into a little bit more difficulty. We notice that that 3/4 in front of the x, that is not allowed in general form. So we want to find a way to get rid of that divided by 4. And the way to do that is we need to multiply the entire equation by 4. So what that's going to look like is, of course, I'm going to multiply the left side by 4, so I'll have 4y, but I am also going to multiply the entire right side by 4. So I'll have 4y is equal to, and if you need some extra practice with fractions and multiplication and adding and dividing and subtracting, feel free to drop me an email, and I'd be more than happy to help you sort that out. So we have 3/4 times 4. So 3/4 times 4, if I were to quickly do this, 3 over 4, and we're multiplying by 4, which means we're taking 4 over 1. We know that in multiplication, we're going to go multiply the top, multiply the bottoms, and we'll get 12 over 4, which is the same thing as 3. Now, if you're looking for something that, as a visual cue, we notice that we have 4 on the bottom and 4 on the top. So your numerator and your denominator will reduce, okay, which gives you 3 over 1, which is just a 3. So let me move that out of the way. So we have 4y is equal to 3x. Now this is a step that's super important. We got rid of that fraction. Now what happens with the 5? We also have to multiply the 5 and the 4 together. So we'll have 3x plus 20. One of the key places where lots of students make mistakes, they forget to multiply that constant or that value of b by whatever factor we tried to multiply everything by. Okay, so again, we have a positive 3x on the right hand side, so I'm going to keep it there. I'm going to move that 4y towards the right hand side. I'm going to do that by subtracting 4y from both the left and the right side, and I'll have 0 is equal to 3x minus 4y plus 20. Okay, question number 4. So again, we have a fraction. We have negative 2 over 5x. So I want to get rid of that 5 on the bottom by multiplying both the top and the bottom by 5. So or not the top and the bottom, the left and the right hand side. So I'm going to multiply the left here by 5. I'll multiply everything in here by 5. So on the left hand side, I'll have 5y is equal to, now again, negative 2 over 5 times 5, that will give me negative 10 over 5. That gives me a negative 2x. And then minus 15. So remember, we want to multiply that negative 3 with the positive 5. That gives me a negative 15. Now because this negative 2x, I don't want that negative there, I can add 2x to both the left and the right sides. So plus 2x plus 2x. I have 2x plus 5y is equal to negative 15. Then my last step is to add the constant 15 to both the left and the right hand sides. So along the bottom now, we're dealing with a whole bunch of linear equations in point-slope form. So with this first one here on the left, we're going to continue to distribute. You have 3 times x, and then 3 times 5. So we're going to have y minus 4 is equal to 3x plus 15. And now since that x is already positive and a whole number on the right side, we're just going to move everything from the left onto the right side. So I'm going to add 4 first. So you have 3x plus 19. Then we're going to subtract y from the left and the right side. And we'll finally end up with 0 is equal to 3x. Clean that up. 0 is equal to 3x minus y plus 19. Example number 2 on this page. Again, I'm going to start with the right side. I'm going to distribute that negative 2, so negative 2 times x, and negative 2 times negative 4. We'll we'll have y plus 9 is equal to negative 2x plus 8. Remember, a negative times a negative is equal to a positive number. Now, since I have a negative 2x here, I'm going to make it positive by moving everything towards the left-hand side. So I'm going to add 2x to start us off. So plus 2x on both the left and the right-hand side. So I have 2x plus y plus 9 is equal to 8. And then I'm going to subtract 8 from both the left and the right side. And I'll be left with 2x plus y plus 1 is equal to 0. Now this is where the fun begins. This is, this is the part where a lot of students start to stumble a little bit, especially if your algebraic skills are a little rusty, but that's okay. We're going to go and start off by identifying what exactly we need to do. And here in this case, we need to get rid of that negative 7 over 2. Essentially what we need to do first is to get rid of that denominator, that number on the bottom. So hopefully what you've seen by now is in order to get rid of any fraction in a linear equation, we're just going to multiply both sides by whatever your denominator is. So in this case, your denominator is 2. So you're going to multiply the entire left and right side, the whole equation, by 2. So to do so, to start us off, we're going to multiply 2 times everything here on the right hand side, and then multiply everything on the right hand side by 2. So what that'll look like is we'll have 2 times y minus 3 is equal to negative 7. This is equal to negative 7, then x plus 4. Now, where students get really confused is, well, what happens to, why aren't we multiplying that 2 with the x and the 4 on the inside? The reason why we don't do that is I could actually rewrite that first portion, that entire right hand side, as negative 7 times x plus 4. All of that's divided by 2. And what we've done here is we've just multiplied the entire thing by 2. So those 2's can reduce each other and nothing actually happens to the inside of the brackets there. So we're only multiplying to get rid of that denominator of that coefficient on the outside. Okay. So we're going to continue and go ahead with the distribution. So we can just do both at the same time. So we're going to go 2 times y, then 2 times negative 3. So we're going to have 2y minus 6. And I'm going to do the same thing on the right hand side, negative 7 times x, and negative 7 times 4. So we'll have negative 7x minus 28. And because we have a negative 7x on the right hand side, we're going to move that onto the left. So we're going to move everything onto the left hand side here. So I'm going to add 7x to both the left and the right hand side. Excuse me. And we'll have 7x plus 2y minus 6 is equal to negative 28. And then our last step is to add 28 to both sides. So I'll have 7x plus 2y plus 22 is equal to 0. Now this last question here, I'm kind of running out of room, so I'm just going to go ahead and move this down here. So we've got y plus 1 multiplied, or is equal to 5 over 7 times x minus 3. So I'm going to go ahead and multiply both the left and the right hand side by 7 because I want to get rid of that denominator. So multiply everything by 7. And we're going to be left with 7 times y plus 1. 7 times y plus 1. Oh, my palm is getting in the way. 7 times y plus 1 is equal to 5 times x minus 3. So we're going to go ahead and distribute everything here. So 7 times y, 7 times 1, 5 times x, and 5 times negative 3. So 7y plus 7 is equal to 5x minus 15. Because our 5x is positive, we're going to move everything onto the right-hand side. So I'm going to subtract 7y and subtract 7 from both the left and the right-hand side. And yes, you can do both at the same time. So we'll end up with 0 is equal to 5x minus 7y, then minus 22 is my final general form there. So on this page here, we are going to go the other direction. We're going to go from general form into slope-intercept form. So remember, in slope-intercept form, our equation is y is equal to mx plus b. So really what we're trying to do is we're trying to isolate y. We're trying to get the y by itself. Okay, so if we're taking a look here, we want a positive y, just a positive 1y. So we're looking at this positive 2y, and we're trying to get that all by itself first. So what that means for us is we're going to subtract 4x, and we're also going to add 12 to both sides. So just for these first couple of examples, we'll go one step at a time. So I'm going to subtract 4x from both the left and the right side. So I'll have 2y minus 12. Oops. Let's clean this up a little bit. I'm going to subtract 4x, and we'll have 2y minus 12 is equal to negative 4x. Then we're going to add 12 to both sides. So plus 12 and plus 12. Then we'll have 2y is equal to negative 4x plus 12. And then our last step here, this is the part, again, where students will get a little bit confused. I have a 2 times y there. So in order to get rid of that coefficient of 2, I'm going to divide the entire equation by 2. So that means that I'm going to divide everything on the right-hand side by 2. So on the left, I'm left with y is equal to, and then on the right, negative 4x divided by 2 gives me a negative 2x, and 12 divided by 2 gives me a positive 6. So my slope-intercept form of 4x plus 2y minus 12 is equal to 0 is just y is equal to negative 2x plus 6. Example number 2, we notice here that my y is a negative 3y. So all I need to do is I need to add 3y to both sides. So again, part of the problem solving process here is trying to make it as efficient as possible when you're trying to isolate for y. You don't want to do more than is necessary. So we're going to go ahead and add 3y to both sides. So add 3y, so plus 3y and plus 3y. And then we're left with a 15x minus 3y, or not 3y, sorry, plus 21 is equal to 3y. So we notice here on the right hand side we have a 3 times y. The opposite operation is just dividing everything by 3. So I'm going to do that on the left and the right hand side. So I'll be left with 5x plus 7 is equal to y. Question number 3. I'm going to go ahead and see that we have the 8y, we have a positive y, so I'm just going to keep it on the left side. And I'm going to, actually, you know what, we can change it up a little bit, and hopefully this will give you guys a chance to see that, hey, we can actually move one thing and then get the same kind of result. So we're going to subtract 8y from both the left and the right hand side. And at this point, you're probably really confused. Why would I do that? Why would I want a negative 8y? And oftentimes I get students to avoid the negatives because it can get you guys into trouble. Just because a lot of students are really uncomfortable with negatives, so it's okay to avoid using them. But let's go ahead and try it out. So this will leave me with 24x plus 14 is equal to negative 8y. So all I need to do now is divide both sides by negative 8. So I'll be left with, if I go 24x divided by negative 8, it gives me a negative 3x. So negative 3x. And then plus 14 over negative 8. So 14 over negative 8 can reduce to negative 7 over 4. So minus 7 over 4 is equal to positive y. So here we have a slope of negative 3, and our y-intercept is a negative 7 over 4. Let's take a look at this bottom row. So you have 3x minus 5y plus 4 is equal to 0. So we're going to go ahead and try to isolate for that y on the bottom. So my first step is to go ahead, I'm going to add 5y. Add 5y to both the left and the right hand side. So plus 5y and plus 5y. So I have 3x plus 4 is equal to 5y. Divide both the left and the right hand side by 5. Oops. So divide those both by 5. And I'm left with 3 over 5x. 3 over 5x plus 4 over 5 is equal to y. So here I've got a linear equation where my slope is 3 over 5 and my y-intercept is 4 over 5. It is perfectly okay for you to have decimals or fractions in slope-intercept form. We do not want that for general form. This next one, we got negative 4y plus 4x is equal to 18. So I'm going to keep that y on the left side. So I've got negative. I'm going to subtract 4x from both the left and the right hand sides. Negative 4y is equal to negative 4x plus 18. Excuse me. And then divide both sides by a negative 4. Divided by negative 4, divided by negative 4. And we'll have y is equal to negative 4x divided by negative 4. Gives me a positive 1x, or just x. 18 divided by negative 4 will reduce down to a negative 9 over 2. So minus 9 over 2. So here, y is equal to x minus 9 over 2. This would be a linear equation with a slope of 1 and a y-intercept of negative 9 over 2. And your last example here on this page, we've got 19y minus 8x plus 3 is equal to 0. I'm going to go ahead, I'll do something a little different. I'm going to add 8x, and I'm also going to subtract 3 from both sides. So I'll have 19y is equal to 8x minus 3. So that's just another way that we can do it. You don't have to necessarily keep the y negative, keep it positive. There's a whole bunch of different things that we could do, or a whole bunch of different ways to get to the same exact equation. And we're going to divide both sides by 19. So we'll end up with y is equal to 8 over 19x minus 3 over 19. You can't simplify either one of those. So in this case, you'd have a linear equation with a slope of 8 over 19 and a y-intercept of negative 3 over. Okay, so the work on the previous pages helped us convert general form into slope-intercept form or point-slope form into general form, and we've already converted point-slope form into slope-intercept form. So we already have a couple different methods. Now with general form, instead of converting into another form, what we can do is we can actually find the x and the y-intercept of the line by setting x is equal to 0 and solving for y to find the y-intercept. So essentially what that's going to look like is if we set that x equal to 0, what we're actually doing is, if we're looking at a graph here, we're trying to figure out where is my y-intercept. So in this case, your y-intercept would be this point right there. And then if we were trying to set y equal to 0 and solving for x, we're actually going to find your x-intercept. So in this case, if I were to make another graph, we'd be looking for this point here. So two distinct characteristics using the general form there. So you can plot the x and y-intercepts, and then we can just connect your points using a straight edge. We're not too worried about general form if we're going to, we're not too worried about the slope. If we're going to graph it this way, we can always figure out the slope using the slope formula. Or if we're sketching it on a graph, we can count the number of units that we move up and the number of units that we move to the right or down and to the left. So let's go ahead, try out a couple of examples. So we have 8x minus 4y plus 16 is equal to 0. So when we say x, or set x equal to 0, it means we're going to replace this x here with the 0. So we'd have 8 times 0 minus 4y plus 16 is equal to 0. So 8 times 0 we know is 0. So we'll have negative 4y plus 16 is equal to 0. So we're going to solve for y. Negative 4y is equal to negative 16 because I'm subtracting 16 from both the left and the right hand side. Then I divide both sides by negative 4. So when I divide this side by negative 4, I end up with a y. On the right hand side, when I subtract it by, or when I subtract negative, or when I divide negative 16 by negative 4, I end up with a positive 4. So that means that y is equal to 4 when x is equal to 0. So I actually end up with a point at 0, 4. So 0, 4 is where I end up with that first point. I'm going to go ahead and graph that over here. So 0, 4, right up here. Now for your x-intercept, we're going to set y equal to 0. So that means that instead of having a y here, I'm going to make that equal to 0. So I'm going to have negative 4 times 0, or negative 4 times 0. So that'll look like is we'll have 8x minus 4 times 0 plus 16 is equal to 0. When I simplify it a little bit, I'll have 8x plus 16 is equal to 0. I'm going to move the 16 to the other side. I'm going to subtract 16 from the left and the right side. And then I'm going to divide both sides by 8. So I'll end up with x is equal to negative 2. So x is equal to negative 2, which means I'll have a point at negative 2 and 0. So negative 2, 0 means that I'll have a point right here. And I can go and connect those two points with a straight line. And I'll get something that looks like this. All right, so let's try a couple of examples here. Again, like always, if you guys take a look towards the top right here, there's some extra practice questions that are directly related to this concept. So our first example, we got x plus y plus 3 is equal to 0. Of course, you can always turn these into slope-intercept form. We're not going to do that right now. We're just going to solve this by finding their x and y intercepts and then plotting those and then just drawing a straight line through those points. So to start us off, we're going to look for your x-intercept. So basically when y is equal to 0 is what we're going to look for first. So when y is equal to 0, we'll have x plus 3 is equal to 0 because, I realize I just wrote over it. When y is equal to 0, it means that instead of having x plus y, we'll have x plus 0 plus 3 is equal to 0. So x plus 3 is equal to 0. And then I'm going to subtract 3 from both sides. So I'll have x is equal to negative 3, which means I have a point at negative 3, 0. That'll be my first point there. And then I'm going to try when x is equal to 0. So when x is equal to 0, I'll have 0 plus y plus 3 is equal to 0. So I'll have y plus 3 is equal to 0. When I isolate for y, I'll have y is equal to negative 3, which means I'll have a point at 0, negative 3. So 0, negative 3 comes right down there. And all I need to do is draw a straight line through those 2 points. And our graph looks something like this. Example number 2. We're going to start again with y is equal to 0. So again, when we say when y is equal to 0, I'm saying we're going to have x minus 3 times 0. I'm putting a 0 in the place of that y there. So x minus 3 times 0 minus 3 is equal to 0. We know that negative 3 times 0 is just 0. So we're going to be left with x minus 3 is equal to 0. And then I'm going to isolate for x. So I'll have x is equal to positive 3. So we'll end up with a point 3, 0. So 3, 0 is right over here. And then we're going to solve for when x is equal to 0. Now in this case, because x is equal to 0, we're going to have 0 here. Then we'll have negative 3y minus 3 is equal to 0. I'm going to add 3 to both sides, so I'll have negative 3y is equal to positive 3. And then divide both sides by negative 3. So I'll get y is equal to negative 1, which means I'll have an ordered pair of 0, negative 1. So I'm going to go ahead and plot my y-intercept there. And then I can draw a line through those 2 points. Third example, you've got 4x plus 2y minus 2 is equal to 0. Again, we can start with y is equal to 0. So when y is equal to 0 in this case, it means that I'm going to have 4x plus 2 times 0, which is 0, minus 2 is equal to 0. So I'll be left with 4x minus 2 is equal to 0. I'm going to add 2 to both sides. And then divide both sides by 4. That'll give me 2 over 4, which I can reduce to 1/2. So that means that my point here is going to be 1/2, 0. Then when x is equal to 0, so when x is equal to 0, what that means is instead of having 4 times x, I'm going to have 4 times 0 is 0. 2y minus 2 is equal to 0. I'm going to add 2 to both sides, so I'll have 2y is equal to 2. And then divide both sides by 2, which gives me y is equal to 1. So I'll have an ordered pair of 0, 1. So 0, 1. And then we said 1/2, 0. So we'll get something that looks like this. And we can go ahead and draw a straight line through those 2 points. All right, last 3 questions of today. We're going to do the same thing. So we've got when y is equal to 0, we'll have 3x minus 18y, so 8 minus 18 times 0. So this whole middle term will disappear. So we'll be left with 3x plus 9 is equal to 0. We're going to subtract 9 from both sides. So if 3x is equal to negative 9. And then I'm going to divide both sides by a positive 3. And I'll have x is equal to negative 3. So I'll have an ordered pair of negative 3, 0. So I can put a point down there. And then when we have x is equal to 0, I'll have 3 times 0, so that whole first term disappears. I'll have negative 18y plus 9 is equal to 0. I'm going to subtract 9 from both sides and then divide both sides by negative 18. So negative 9 divided by negative 18 gives me a positive 1 over 2. So that means that my ordered pair ends up being 0, 1/2. So somewhere over there, and I'll draw my straight line through those 2 points. It's a little bit crooked. Let's go ahead and fix that a little bit. And there you go. The second example on this page. So when y is equal to 0, it means that this whole middle term is going to disappear, and we'll be left with 18x minus 24 is equal to 0. 18x minus 24 is equal to 0. I'm going to add 24 to both the left and the right side, and then divide both sides by 18. So 24 over 18, that can be reduced to 3 over 2. So I'll have a point at 3 over 2, 0. So 3 over 2 is roughly, or is 1.5. So we're going to go right here. We know we have our x-intercept right there. And then when x is equal to 0, that whole first term will disappear. So we'll have 12y minus 24 is equal to 0. And then we're going to add 24 to both sides. And then divide both sides by 12. So we get y is equal to 2. So I'll get an ordered pair of 0, 2. I can go ahead and draw a straight line through those 2 points. And our graph looks something like this. So again, we're not super concerned about the slope here. That's not the point of this exercise. It's just for you guys to see that we can find the x and the y-intercepts using general form and still be able to plot a line that is that represents exactly what that equation is. Now, our final example of today's video, we're going to go and once again start off with y is equal to 0. When y is equal to 0, our whole middle term here disappears. So we'll have 3x plus 5 is equal to 0. I'm going to subtract 5 from both the left and the right hand side. So I'll have 3x is equal to a negative 5. Then I'll divide both sides by a positive 3. So I'll get x is equal to negative 5/3. So I'll have a point at negative 5/3, 0. So negative 5/3, we're going to put it right about here. And we'll have x is equal to 0. So that means that my entire first term disappears. Negative 12y. Oh. Negative 12y plus 5 is equal to 0. I'm going to subtract 5 from both sides, so negative 12y is equal to negative 5. Then divide both sides by negative 12. Negative divided by a negative is a positive number, so I'll end up with 0, 5, 12 as my ordered pair. So 5 over 12 is just under 1/2, so I'm going to go somewhere over here. And we can draw a line through those 2 points. So again, you probably noticed that this video was very algebra intensive. I'd like to refer back to my video on solving algebraic equations if you need a bit of a refresher. Again, feel free to send me an email if you're having any questions, and I'd be more than happy to get back to you about those. Until then, I'll see you in the next video. Keep washing your hands.